We are often interested in understanding the nature of the relationship between two variables, where one of these variables, which we call the dependent variable, is the variable to be estimated or predicted, and the other variable, which we call the independent variable, is the variable that will be used to estimate or predict the value of the dependent variable. If the relationship between the dependent variable and the independent variable is linear, then simple linear regression is an appropriate statistical tool for assessing this relationship. The Butler Trucking Company would like to assess the relationship between the time it takes a driver to complete a driving assignment and the distance of the driving assignment. This will enable Butler Trucking to use the distance of a driving assignment to estimate the time it will take to complete the assignment. Butler Trucking can then use this model to plan its deliveries more effectively and use its resources more efficiently. In this example, the dependent variable will be the time it takes to complete an assignment, and the independent variable will be the distance to be driven to complete the assignment. Data have been collected from a sample of 10 Butler Trucking Company driving assignments. The data collected by the Butler Trucking Company are shown in this table. For the ith observation or driving assignment in the sample, xi is the miles traveled and yi is the travel time in hours. We see, for example, that driving assignment 1 with x1 equals 100 and y1 equals 9.3 is a driving assignment of 100 miles with a travel time of 9.3 hours. Driving assignment 2 with x2 equals 50 and y2 equals 4.8 is a driving assignment of 50 miles with a travel time of 4.8 hours. The Butler Trucking Company would like to use these data to develop a linear equation that can be used to estimate the amount of time and hours it will take its drivers to complete driving assignments of various lengths. We will use Excel to estimate a linear regression model with these data. We will now estimate a simple linear regression model using the data collected by Butler Trucking. The data for this problem have been entered into columns A through C. The numbers identifying the driving assignments are in column A, the miles driven for each assignment in column B, and the time and hours it took to complete each assignment in column C. We first go to the ribbon and click on Data. We then click on Data Analysis in the Analyze tab. This opens up the Data Analysis dialog box. If regression is not highlighted in the Data Analysis dialog box, scroll through the options until you find regression. Then click on Regression and click OK. This opens up the regression dialog box. Now enter C1 to C11 in the Input Y range box. Similarly, enter B1 to B11 in the Input X range box. Click on Labels to indicate the first entry in each column is a variable name. Then click on OK. Excel creates a new worksheet and outputs the results of your regression analysis to this new worksheet. The Excel output has a great deal of information about our simple linear regression model. We discuss how to interpret and use much of this information later in our discussion of regression analysis, but for now we are interested in locating what we call the slope and the y-intercept for our simple linear regression model. We find the slope and the y-intercept in the column labeled Coefficients in the table at the bottom of the Excel regression output. We see that the y-intercept, which Excel refers to as the intercept, is in cell B17. Its value is 1.2739. We also see that the slope, which Excel labels with the name we gave to the independent variable, is in cell B18. Its value is 0.0678. Our simple linear regression model tells us that the estimated time in hours to complete a driving assignment is 1.2739 plus 0.0678 times the distance in miles of the assignment. If we know the distance in miles of a Butler Trucking driving assignment, we can now use the simple linear regression model to estimate the time and hours it will take the driver to complete the assignment. For example, if Butler Trucking has to assign a 60-mile trip to one of its drivers, we can use Excel and our simple linear regression model to estimate the number of hours it will take the driver to complete the assignment. We will now enter the heading miles in cell A21 and the heading estimated time in cell B21. In cell A22, we will enter 60, which is the value for miles for our example. In cell B22, we will enter the formula equals B17 plus B18 times A22. Return. The result in cell B22 indicates that after rounding to 4 decimal places, we estimate that it will take 5.3435 hours to complete this 60-mile driving assignment. We could estimate the time to complete a 61-mile assignment in a similar manner. We enter the value 61 for miles in cell A23. In cell B23, we enter the formula equals B17 plus B18 times A23 and hit enter. The result in cell B23 indicates that after rounding to 4 decimal places, we estimate that it will take 5.4113 hours to complete a 61-mile assignment. Now consider the difference between the estimated time to complete a 60-mile assignment and a 61-mile assignment. We see that the difference is 0.06782. This is the estimated additional time it takes if we add 1 mile to a driving assignment. This is also equal to the estimated slope in our simple linear regression model, which is in cell B18.